Hello everyone, welcome to Aptitude course lecture 3. So let us recall previous lecture. So previously we had a discussion about different types of numbers, whole number, decimal number, real number and natural number and so on, integers. So the finally we conclude that there is a set of two numbers, real number and decimal number, and both are same and both are it is a different format, and any number we can write in the form of decimal number. So now coming to the arithmetic operations, we discussed different notations and different symbols in arithmetic operations, addition, subtraction, multiplication and so on. Now we already done how to convert decimal number into fractional number and fractional number into decimal number, vice versa, and we can call it as this fraction number, rational number or fractions. And we know very well to convert the decimal number into percentage and percentage into decimal, where we have to do the multiplication 100 and division of 100. Okay, so now coming to the today's lecture. So today we are going to discuss in detail of the basic arithmetic operation. So we will discuss how to do the in a simple way addition and subtraction and multiplication and division. We are going to discuss these four operations, and after that we will go to the squares and cubes, how many up to which squares and cubes we have to remember, and we will go to the unit digits of exponential number, that is nothing but it's a power numbers, and we will see rule of divisibility and how to find out the prime numbers also. So let us coming to the basic arithmetic operation. So let me change the ink color, so that is better way. Okay, right. Now whenever we are doing the addition, first of all if you see the addition, then we have to keep it in mind wherever the numbers is coming to the round values. For example, if I add the 8 plus 2, then it will come 10. So whenever 2 and 8 will come, or 8 and 2 will come in addition operation, you can say it is very simply you can remember the 10. So similarly it is the 3 and 7 and 4 and 6 and 5 and 5. Okay, so these numbers will give the 10, and you have to remember in a speed calculation, and this one come by practice only. Okay, you have to do the more practice. So now coming to the subtraction. Now if any number you are doing the subtraction 9 and there is a hint, you have to increase the plus 1 in the unit digits, and you have to decrease the plus 1 and plus 1, decrease the plus 1 in the 10th digits. What it is actually meaning? So if you are doing 486 minus 9, now increase the in unit place 1, so that is 7, and decrease the plus 1 in the 10th place, so 477. So this is the answer whenever you are doing the minus of 9. Now similarly it will come 8 also. So if you do the 8 and you have to increase the in unit place plus 2, and you have to decrease the 10th place plus 2. So if you are doing same thing in the 486 minus 8, now you have to increase the two values, so that will come 8, and you have to decrease the only one value. So sorry, here it is you have to do the only one value. So now it will come 478. So unit place always it is 1, so it's not 2, because you are not subtracting any two length of number. Okay. Okay, so now coming to the multiplication. So multiplication you are doing in conventional method. For example, 23 into 47, you have to do 4 3s and 4 2s, and again you have to do the 4 3s and 4 2s, and add all these things here. You will make it a star here and do it and adding, and you will get the sum answer. So is there any shortcut or a simple way to do the multiplication of two length of numbers 2 and 3? Yes, it is there. For example, if you see 23 into 47, now the method is same. You have to do the number of calculations in this method or in this method, it will be same, but you will have the simple way or simple manner, easy manner. You can easily you can save the time. Now I will do the first step. 3 into 7, 3 7 are 21. Now I will write 1 and 2 here. So whatever you are writing here in this answer, you will get or you have to write only single number only. If it is 3 numbers will be there, you have to write 2 numbers separately, and one place you have to write it here. Now first step is over. Now go to the second step. 2 7 ja and 3 4 ja, add them these two. 2 7 ja 14 and 3 4 ja 12, and 14 plus 12 it is 26, and 26 plus 2 it is the 28. Now I will write it here 8 and 2 again. Now 4 2 ja 8, 8 plus 2 it is 10. So answer is 1081. So this 23 into 47. So total how many steps? And 3 steps. If it is length of 2, then it will come 3 steps. Now in a similar way we can do the multiplication of length of 3 numbers also. If you go to the 1 to 3, multiply 4 5 6, then I can easily do that. Now first step. Now if it is length of 3, it will come 5 steps, or let us look that whatever the 5 steps. So first step, 3 into 6, 3 6 the 18, and I will write 1 here separately, and 2 6 the 12, and 3 5 the 15. 12 plus 15 it is the 27, 27 plus 1 it is the 28. Now I will write it as 2 here separately. Now 6 this is the somewhat it is length step. 6 1 ja and 3 4 ja and 2 5 ja. So 6 1 ja 6, 3 4 ja 12, 12 plus 6 it is 18, 18 plus 2 into 5 it is 10, it is the 28, 28 plus 2 it is the 30. Now I will write 3 here. Now 5 1 ja 2 4 ja, it is the 2 4 ja 8, and 5 1 ja 5, it is the 13, 13 plus 2 it is the 15. So I will write 1 here. Okay, sorry, I have to add up these 3. So 2 4 ja it is the 8, and 1 5 ja 1, 8 plus 5 it is 13, 13 plus 3 it is the 16. So 6 it will come. Now so 16, 1 is remainder. So 1 4 ja 4, and 1 plus 4 it is 5. So 56088. So 56,088 it is the answer. You can check with the calculator also. So let us coming to the multiplication of 4 numbers. So these 4 numbers will not give the maximum number of times in the competitive examinations. That much of lengthy number will not give. Why? Because it's a time permits. Time is very maximum up to 3 you can use full 5 step. So if it is 4 numbers, length is there, then you have to do the 7 steps. So now what is the steps? I will just make the notations with A B C D. Then you have to pause the video slowly. You can remember the whatever the steps. Now first step I will do D into H, second step CH and DG, and third step BH and DF and CG, and fourth step AH, DE and BG and CF, and fifth step AG, CE and BF, and the sixth step AF, BE, and the seventh step AE. So you will get the 7 steps number here. It might be larger than the 7. So you are done 3 steps, but you got the 4 number of here the digits is 5 digits. So you may get more than 7 digits here. Now coming to the division. So in the division you have to do the very easy way. It will come in the practice only. For example, this I will see the 19 by 3. Now how we are doing 319, and here, so here I want to emphasize the terminology in the division. So this is called divisor, and this is called dividend, and this is called whatever here it will come quotient, and here it will got if 3 6 18, and this will called remainder. Now so how we can get this 19 in place of 3? So the 19 is equal to 3 into divisor into quotient, and plus 1. So this 19. Now 19 by 3, how can I write? 6 into 3 and plus 1. So I can write it this one 19 by 3. First I will write this 6 quotient, and I will write 1 by 3. So this 1 is the remainder, and this 3 is the divisor, and this 6 is the quotient. So this format also I can write. See, 3 6 18, 18 plus 1 19 upon 3. The denominator is 3. So I can eliminate in the different notation. So 19 by 3, now I will eliminate plus symbol. So 6 1 by 3. So I can write it in this manner also. Now we understood this is the integer part what we are discussed in the decimal number, and this is the fractional part or decimal part. So can I write it in the decimal number? Yes, you can write it. 6 is the integer part, so 6 plus this fractional part, decimal part, I can write it as the 3 bar. We know very well 1 by 3 is equal to 3 bar. So this is the notation, and this is the connection between the division decimal number and the fractional number. So how can I do the in a easy way of this division? So for that you have to do the more practice. Easiest way, for example, if it is 201 upon 3 is there, so don't do the 3 and 201 and 3 6 18 and 2 1 3 7 21 and 0. So just do that 3 1 ja, and now I know that this 201 is divisible with 3. We will see in divisibility rule, because 2 plus 1 is equal to 3, 3 is divisible by 3. So now 20, so 18 3 6 ja 18 and 2 will come, and 2 and 1, so 3 7 ja 21. So now I am getting 202 upon 3, the answer is 67. So that is the quotient. Now so now we are done this division part also. So we know very well to how to do this division. So in this way you have to do the more practice. By practice only it will come. You have to do the more practice, right? Now coming to the squares. So how many squares you have to remember in this course, entire course, to do the aptitude? So maximum up to 1 to 3 squares or 30 squares you have to remember. So you know well about these up to 10, because we are very familiar, or we are frequently somewhat in our 8th standard, 9th standard, we are done 1 to 10. It is easily to remember. So 1 to 10 tables also we heard this 2 5 5 is 25, 6 6 is 36 and so on. Now coming to the 121. So these are the same color, so I will change the color. Okay. So 121, it is easily remember for the 11 1 and 1. So for this number x a and x, and end starting it will come same numbers. Like that there is a another number also, 484. 22 whole square is equal to 484. 11 whole square it is equal to 121. So what is the speciality of this number? Starting and ending with same number, same digit it will starting and end with the same digits. Now coming to the 12 whole square 144. Now these two has the another speciality. The 69 will reverse to the 196. Whenever you are keep it in mind, 13 whole square 169 and 14 whole square is equal to 196. This 96 and 69 it will reverse. So this is the 13 whole square, this is the 14 whole square. Now coming to the if there is a special rule in squares, if the digits unit digit is 5 will come, and there is a speciality. If unit digit will come 5, and you can write it as a 25 is the end, and you can write here x into x plus 1. So this is the shortcut of if the 5 is unit digits in the squares number. For example, 15 whole square is there. Now I will simply write 25. I have to write it is what it is, x into x plus 1. In x plus 1 is there, so 1 into 1 plus 1 it is 2, 1 into 2 it is 225. So we can easily remember. Now similarly 25 whole square. 25 whole square is equal to, I can write 25 here, and in x plus 2 is there, x into x plus 1, 2 into 3 it is the 625. Similarly 35 whole square, 3 4 ja 12 and 25. And similarly 45 whole square, so 4 5 is 20 and 5 whole square it is 25. So always 25 will come. See, 5 whole square 25, because here it is 0 is there, 0 into 1 it is the 0. So 15 whole square, 1 2 is 2 and 25, 2 3 is 6, 2 3 is 6 and 625 and so on. See, now this is also over. Now 16 whole square, 256, 289, 324, 361, 400, at anyhow you have to remember. And we know well this 10, 20, 30, 40, because it is repetition. If 10 whole square it is 1 0, and 20 whole square there is a 2 zeros. Yeah, here it's also 2 zeros will come. This is the nothing but it's a 1 square, 2 square, 3 square, because whenever it is 0 whole square is there, in answer it will come 2 zeros. See, okay. Now coming to the 21 whole square, this is the 441 and 529 and 576. So if you remember 441 and 484 and 529 and 576, it is easily remember to 26 whole square, 27 whole square, 28 and 29. How it is? See, this 76 will repeat in the 26th whole square. So 576 here, but here it is the 776. So this 76 will repeat in this the next number. Now similarly this 29 will repeat to the 27 whole square, 729. Now this 484 it will repeat and 784. Now this 441 it is the 841. See, so this is the connection between the this 4 whole squares and these 4 whole squares. Okay, now coming to the squares, cubes. So before going to this cube, so I want to write some power notations. Cubes or squares is nothing but exponential number. So I want to write it here, some formula. A to the power of m and whole to the power of n is equal to a to the power of m into n. Now a to the power of m into a to the power of n is equal to a to the power of m plus n. Similarly, a to the power of m upon a to the power of n is equal to a to the power of m minus n. So for sake of convenience, only these formulas we are using in this class. So if it is another formulas will repeat, and I will tell that. Okay. Now and similarly another number also there. For example, so a into a into b whole to the power of n is there. So a to the power of n into b to the power of n. So this is also helpful. Now 1 cube, 1, 8, 27, 64, 125, 216. It is easily remember. Now for this formulas, whatever the formulas I wrote, I can use this 6 cube is equal to 6 cube. What is, how can I write 6? 2 into 3. So it is the whole cube. Now 2 cube into 3 cube. Now I know that 2 cube into 3 cube very well. That is the 8 into 27. So 8 into 27 is nothing but 216. You can remember whenever the 27 into 8 it will come 6 cube. So you can remember this link. So that is 8 into 27 it is nothing but 2 cube into 3 cube, it is the 216, that is the 6 cube. Now 343. Now it is also again famous number, because 121 that is the 11 whole square, and 484 it is the 22 whole square, and 343 is equal to 7 cube. So you can remember. And 512. Okay, here there is a beauty on that. So what is that? And we know very well 2 to the power of 10 is equal to 1024. That is the, we are measuring MB is equal to 1 GB. Now in previous days, 20 years, 30 years back, there is a 512 MB because half GB. So half GB, how can I write? 2 to the power of 9 is equal to 512 MB. 512 MB memory cards are there. If you see the 20 years back, then that is the half GB. Now coming to the 2 to the power of 8 is equal to 256 MB, that is the 1/4 of GB. Now is this any relation 512? Yes, 8 cube is the 512. How can I write? So 2 to the power of 9, I can write 2 to the power of 3 into 3. Now I can write 2 to the power of 3. So this 2 to the power of 9 I am writing. 2 to the power of 3 and 3 whole cube I can write by this formula. So now I will get the 8 cube. So 8 cube is nothing but 2 to the power of 9, 512 MB. We can easily remember. Now 729. We just got this 729 in 27 whole square. If you see this squares, 27 whole square, how why did this 27 come, and 529, that is 23. Now how can I write this 27 whole square and 9 cube? We can easily convert 3 into 9 and whole square. Okay, now so this okay, so I will make it as a 9 whole cube. So 3 into 3 whole cube, so 3 whole cube and into 3 whole cube, so that is the 27 into 27, and I can write it as a 27 whole square. So there is a lot of methods. See, this 9 cube I can write it as a 3 into 3 whole cube, and 3 cube 3 cube, this is the this is the formula. Now 27 whole square I can write it as a 3 whole square. Okay, now I can make it as a this 27 whole square. Okay, so now this is nothing but 27 whole square, and 10 cube we are well known to remember. Now what is the difference between square and square root? Okay, so for example, if x to the power of n is equal to some y is their value. Now if I am transferring this n to this side, y side, so x is equal to, it will come inverse 1 by n. Now this 1 by n we can write it in the notation nth of y. So if it is 1 n place, if n is equal to 2, now I can write it as a x is equal to nothing but it's a square root of y, because here 2 is there. Now if n is equal to 3, in n place if 3 is there, now x is equal to, I can write it as a cube root of y. So this cube root or square root is nothing but it's a inverse of square and cube. Now how can I write it? For example, this 27 whole square is equal to, I can write it as a 729. Now this 27 is nothing but it's a square root of 729. Though, so this 2 will become, it is the 729 power 1 by 2, that is the square root. So this square root I can write, this is the 1 by, power is 1 by 2. Now this cube root I can write in this notation, it is the nothing but it's a power of 1 by 3. Now same thing I can write this 9 cube is equal to 729. Now this 9 is nothing but it's a cube root of 729. So maximum notations, many notations, they are not indicating 2 here, because we know this is the, if it is not any number is there, default you can take it as a 2, that is a square root. That is the terminology, and that is the difference between square root, cube root, and versus square and cube. Now coming to the unit digits of exponential number. So exponential number means it is the x to the power of n. So in n it will come a natural number. Okay. Now coming to that, I will write start with the second table. 2 to the power of 1 is equal to 2, 2 to the power of 2 is equal to 4, and 2 to the power of 3, so on, 8 and 16, and 16 to the 32 and 64 and 128. Now I will stop here. So 2 to the power of 4, 5, 2 to the power of 6, and 2 to the power of 7. Okay, so I can write it as 128 256, that is the 2 to the power of 8. Now if you see this clearly in unit places, you are realized that in unit place 2 is there, 4 is there, 8 is there, and 6 is there. Now these four numbers again repeating after the 5, 6, 7, 8, so on. See, this 2 is repeating 4, 8 and 6. Again it will come another pattern 2, 4, 8, 6. So that means in 2 to the power of x, in place of x, whatever the numbers will come, if you started with the 1, it will repeat the sum pattern in the unit places, that is the 2, 4, 8, 6. Now if you see the 3 to the power of x, so now this x is equal to, you have to write 1, 2, 3, 4 and so on. So x is the set of natural number. I can write it as x is the set of natural number. Now x 2 to the power of 1, 3 to the power of 1, 3, 9, 27, 7, 27 3 is a 7 3 is a 21, it is 1. 1 into 3, again it will repeat. Now if you remember these two numbers, it is very easy to remember the 7th number and 8th number. So 7th number, it is started with here the 7th, you can write it as the 7th number 7, 9, 3, 1. Now it is the 8th number 8. If any power or exponential is there, it will repeat 8, 4, 2, 1. So this is the very easiest way to remember the unit digits when 7 and 8. If you know the 2 and 3, you are very well known 8 and 7. Now coming to the 6 and 5, it is the one beauty is there. 6 and 5, if it is 6, only 1 will come. 6, whatever it is, see, in 6 to the power of n, whatever it will come in x place, x is a set of natural number, it will come 6 only. And similarly 5 also, it will come 5 and 0. So for this 5, it will come 5 only. So it will not come 0, only 5. So these are the only two numbers will come. Now coming to the 4. So for that 4, 4 1 4 and 4 4 16 and 6 4 24. Now it is again repeating. So coming to the 9, 9 4 9 1 9, 9 9 81, 1 and again 1 into 9 9. So these are the 4 and 9. So 1 is over, 1 is 1, always will come 1. If it is 1, it is 1. Now 2, 3 and 4, 5, 6, 7, 8 and 9 is over. So we will see one simple number. For example, 248 whole to the power of, for example, 173. Now, so what number, for example, there is a different numbers here, so many numbers, but what it will come at the end in unit place. Now see, now I will write if it is see, here unit place 8 is there. So 8 whole to the power of 173. If it is 8 to the power of 1, it is 8, 4 and 2, 1. 8 to the power of 2, 3 and 4. Okay, here somewhere we wrong. It is 6 actually. 2 8 it is 6. Yeah, this one. Okay, now I will divisor with 173 upon 4. So this is the 4 or 0. So 4 it is 16 and 1 3 and 4 3 is 12. That means the remainder is 1. See, if I am division with 1 is 4, remainder is 1, remainder is 2, remainder is 3, remainder is 4 or 0. Remainder 4 will not come. Anyhow, you have, if you are divise with 4, remainder will come 0. So that means if it is this number is divisible with 4, you will get the unit place is 6. If you divisible with this number with 4, if you got the multiply with 1, that means up to 172 it will come. 172 what it is? It is simply division with 4 and it is 0. If it is 174, you will get the 6. If it is 173, you will get 8. So here the answer is 8. If it is 174, you will get 4. 175, 2. 176, again it is divided with 4, it is 0. For example, now I will write another 2 digits number will do. Now if it is 126 whole to the power of 126, you will get the 6 only. Here 6 is there, whatever it is, you will get the 6 only. Similarly 125 also, 125 whole to the power of 125, unit place it will come 5. Now coming to the, we will do the 9. For example, 249 whole to the power of 173. Now you have to divide with 173 upon 2 only. Now you will get the remainder is 1, so you will get the 9 only. If you got remainder 2 are divisible with 1, for example if it is 172 is there, you will get the 1 only, because it is the 0 or 2 remainder. So it is the way you have to do that, because here the repeating patterns or numbers is 4, so that's why I am dividing with 4. Here repeating pattern numbers is 2, so that's why I am dividing with the 2. So that is the reason. We will see more number of questions in the next class. Now coming to the rule of divisibility, yeah, it's a very important thing. So if it is 2 and 1 is any number we can divisible with 1, and 2 is the only even numbers we can divisible with the 2, odd numbers we cannot divisible. Now coming to the 3, whatever the number, how to divisible with 3? So that sum of digits of number, so sum of digits of number should be division with 3. For example, I am already told this 201. What is the sum of digits? 1 plus 0 1, and 1 plus 2 it is 3. So sum is 3. So 3 is divisible with 3. So that 201 is divisible with the 3. Now coming to the 9 also same thing. So sum of digits should be divisible with the 9. Now is this 201 is divisible with 3? No. If it is 207 is there, yes, we can divisible with the 9, because 7 plus 0 7, 7 plus 2 it is 9. So 9 is divisible with the 9. So you can check it, this 207 is divisible with 9. Now coming to the after 1 2 3 4 will come. So 4, that last 2 digits should be divisible with the 4. Now similarly 8 and 16 also there. So last 3 digits should be divisible with the 8, and the 16 also last 4 digits should be divisible with the 16. Now 1 2 3 4, now 5. Coming to the 5, so the last digit or unit digit, so we can say it is the unit digit. Unit digit should be either 0 or 5. So if the last digit is, for example 210, it is divisible with 5. For example 215, it is divisible with 5. 214, it is not divisible with the 5. So last digit should be 5 or 0. Now coming to the 6. Now that number, whatever that number should be divisible with 2 and 3. So whatever the number, for example if you see the 201, it is divisible with 3, but it is not divisible with 2. So that is the reason 201 is not divisible with the 3. For example one number I will take 306. Now 6 plus 3 is 9. 9 is divisible with 3. So it is divisible with 3. Yes, it is divisible with 3. It is divisible with 2. Yes, it is divisible with 3, because it is the even number. So that means the 306 is divisible with the 6. Now coming to the 7, and 7 there is a no shortcut. So there is a no shortcut for that 7. Now 8 already we discussed, 9 we already discussed. Now coming to the 11. 11 is the one beauty is there. So the beauty is that the difference of odd places of digits and even places of digits should be either 0 or multiple of 11. Multiple of 11 means 11, 22, 33, 44. These are the multiples of 11. Now coming to the, what is that actually? See, for example 121. Now what is the odd place? These are the odd place, 1 2 3. If you are so on writing the number from right to left, these are the odd places. Now 1 plus 1 it is 2. Now even place also 2. So what is the difference of this? 0. So that is the reason the 121 is divisible with the 11. Now coming to that, if you are see 121 and 121 and 121, now make it as a 1 2 3 4 5 6 7 8 9. So 1 places, these are the odd places, 1 2 and 2 plus 2 4 and 4 plus 1 it is the 5, 5 plus 1 it is the 6. So odd places 6, even places 2 and 3 and 4 and 5 and 6. So this is also 6, the difference is 1. So this number definitely it is the divisible with the 11, you can check it that. Now in this place we are getting the 0, or you can get the 11 or 22 or 33, the multiple of 11 you can get. So or we can simply multiple of 11 we will never get, that is the chance we can get, but simply we can remember 0 or 11 most of the times. But if you get 22 33, that's well. Or we can say it, that number, what is the number, should be divisible with 11, either multiple or either divisible with 11, you can say that. Now coming to the 12, so 12 we can it should be the number with divisible with 3 and 4 and many numbers with there, so that is not that much of importance. Okay, now coming to the prime number. Okay, that's one of the important concepts. So whatever the number is there, that number we have to see the square root, and after the square root whatever number I am getting, so up to square root how many primes are there, we have to see the, is this number divisible with up to square root the prime numbers, then we will see a decision whether it is a prime number, will this number is prime or not. So we will write up to 20 numbers prime numbers. So 2 is the prime number, 1 is not a prime number, 2 3 5 7 and 11, so 12 13 and 14 15 16 17 and 18 19 and 20 21 and 22 23 and 24 25 26 27 28 and 29. So up to 30 here. Now I am writing 241. Now is this any square root? Okay, I know very well 225 is the square root of 15. Yeah, this is the square root of 15. Now 225 is square root of 225 square root is 15. Now 256 is the square 16 whole square. Now where it is 241, it is the greater than 15 and less than 16. So we have to see this 241 is less than 16 whole square. So we have to see all the prime numbers, whatever the prime numbers up to 16, less than 16. So it should not 16, but it is less than 16. 15 we can take. We have to see the all the prime numbers. How many prime numbers? 2 3 5 7 11 and 13. 17 is greater than 16. We have to see all these numbers, is it divisible, any number, if it is divisible of this 241, then we can say it is the not a prime number. If it is not divisible any number, so then we can say it is the prime number. Let us see, if any number is not divisible, then it is prime. If any number is any out of these 6 numbers, any number it is divisible, then it is not prime number. So we will see 2. Now 241 is not a even number, so 2 is not divisible. So 3. Now this 4 plus 1 it is the 5, 5 plus 7, 7 is not divisible with 3. 5 we can get because unit place it is 1 is there. 7, so 24 1 7, 7 3s are 21 and 3 and 1 and 31 is not divisible with 1. Okay, 1 and 2 it is the 3. 3 and 4, the difference of 3 and 4 odd places even place it is 1, so you have to get 1 or 11, so 11 is not divisible. So let us see 13. So 13 1 ja 241, 13 1 ja 13, so 11 we are here, and 111 it is not divisible with 13. So none of the number is divisible of this 241, so that we can easily conclude that this is the prime number. So 241 is a prime. So if any of this out of these numbers less than 16, if it is divisible with any number divisible of this 241, then we can say it is not a prime. Okay, yeah, you can do that, you can check many numbers. First we have to do the square roots. So that is the reason square roots and squares is important to finding the whether the number is prime or not. Yeah, thank you.